Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hello, I'm Ed.
And this week we're going to talk about Internet of Everything. We're going to kind of, wrap up a lot of the stuff that we've been talking about in, the past episodes, IoT, IIoT, the OT versus IT, and also, the MQTT stuff along with a couple of the visualization topics, is kind of some stuff that we're aiming for and, that we're going to be talking about this week. So, and when we talk about, Internet of Everything, what are you kind of thinking about?
So what I'm thinking about is four areas. I'm thinking about people, process, things, and data. And how do we take all of these things and incorporate them into one big bucket? And from that bucket, we pour that out and get information that we can utilize or monetize. Yeah. Because every business wants to be profitable and every business owner wants to make a profit.
Right. And, I think with that, time is money, money is time. And if, we can take, all this data, compound it into one and, throw it out like on a KPI sheet or something like that, if the because KPIs don't lie, unless if they're automatically inputted. If they're manually inputted, they can lie. If they're automatically inputted, they can't lie. And with that, if we have our KPIs set up, especially using, all of our sensors and stuff like that and predictive maintenance and whatnot, we start thinking about, how we can reduce downtime, reduce dwell time and stuff like that in the process.
And then another thing to think about is value. So it is estimated that about $14.4 trillion are at stake with this new technology, if it's utilized right. Yeah. And what I mean by utilized right, Nick, is if you bear with me just a second, what I mean by that is when we talk people and we talk process and we talk data and we talk things, what do we mean? We mean that we're connecting all these things together. Right. And as Nick says, there is no more erosion of the truth when I look at the data. When I'm talking things, everything that's in my infrastructure, everything that's in my enterprise is giving me feedback. So now I can take all those things and utilize it. And then people are doing things that are not, I would say, remote or redundant. They're actually using their brains and coming up with innovations and finding problems and fixing things, as opposed to someone walking around with a clipboard write down tick marks.
Yeah. And the thing is I'll say this, that goes back to one methodology. The entire process goes back to one set of methodologies, Industry 4.0. Industry 4.0 is going to be the game changer. It already is the game changer. We already see it starting. We see some of the heavy hitters out there, really adapting to Industry 4.0. If you think about it, the first company to actually do it was Amazon. We talked about like your Amazon Alexas in your house and stuff like that, your Roombas and stuff like that. They brought the Industry 4.0 methodology into the house before Industry 4.0 was a thing. And now we start dealing with some of our bigger suppliers and stuff like that in the realm of MQTT and stuff like that, where we're pulling from our AGVs, from our solenoids and our PLCs and stuff like that, and correlating this data back to where it needs to be, on top of getting drive motors and stuff like that that are smart now.
So, just to piggyback on what Nick's saying, so now I can do human to human. Humans to humans can get real-time data between each other.
Yeah, exactly.
So I can share something with a human without having to sit down and explain all the details, but the details are worked out. I can do human to machine. I can also do machine to machine. And here's the beauty: machine to data, data to meaning, and what we all care about, meaning to value and action.
Right.
That's what we're looking for.
Anything to save a nickel. And that's kind of how it goes. It's like for me, and coming out of the IT side, we start looking at the realms of what is it, like notifications and stuff like that. Kind of like your Cabanas, your Nagios alerts and stuff like that to monitor your mainframes and your back-end servers. So once those things get too high, the hardware can fail out. And then you have to turn around and buy new hardware. A server right now is going for about $35,000, depending on what you need. If you need a hard server to run multiple VMs on it, then it's going to cost you about $35,000. We know that. So if we can put this monitoring in place beforehand, we don't have to worry about that. Because also then you don't have to stop anything.
Here's the beauty of the concept. Right now in a traditional enterprise, there are a number of systems. You have sensors and actuators. You have basic control. You have SCADA systems. You have MES. You have ERP. Each of these systems has their own architecture. Let's put it in a simpler fashion. Each of these systems has its own namespace.
Right.
Set up different in each layer of this architecture.
Yep. Up and spoke.
Imagine, if you will, if I was able to take all of the data at the sensor and actuator level, all of the data at the basic controls level, all of the SCADA data, all of the MES data, all of the ERP data, and say, hey, you go to one spot. And each one said, I only care about the topic that I am concerned about. If the state does not change, please don't report.
Yeah, right. I can agree with that.
Real-time data. Data that has not been eroded. Data that can be used and mined, and data is the new oil. So these things can be put in place. These things can help streamline your company, help you save millions of dollars from what we have traditionally with the old system.
Yeah. And that's like we talk about, like the unified namespace. We go back to the MQTT conversation we had. MQTT is probably the oldest unified namespace you can possibly get when you're talking about, using, namespaces and GUIDs and unified identifiers to talk back and forth. You start talking about, like if you have three different, AGVs reporting on the same network, you can't have one that says AGV1 across the board in the host names. It won't work. Only one's going to report, and it doesn't know which one takes priority. One goes down, the other one takes over, and vice versa. Same thing as what you get IP failover. However, if each one has its own designated 1, 2, 3, environment, each one's going to report down the channels every time it gets a action or an error or anything like that can possibly, save you time. Like if you block a scan field, for instance, if you're using like the Lensa drive, the scans, and stuff like that, or if you get a Lensa drive that gets a little bit too hot, you can know that stuff ahead of time. What can I move out of the way to prevent this from happening?
So the traditional, and I like to start at the base. I like to start where the roots are, which, like I said, is at the sensor and actuator level.
Right.
So at the sensor and actuator level, right now we have one data source. It's either true or it's false. It's either right or it's wrong.
Right.
However, with intelligent sensors, with intelligent actuators, now I can start to look at fuzzy logic. And what is fuzzy logic? Fuzzy logic basically looks at every possibility. It doesn't look at a true or a false. It looks at a almost true or almost false. Could be true, could be false. It considers all these things, and it takes a heuristic approach when it looks at the data. Now I can set up this decision tree processing. Now I can look at anomalies. Now I can see what happens when the power goes out. Maybe the sensor takes 10 seconds before it's all the way off. What's happening in those 10 seconds?
Yeah,
Those are data points.
right.
That's data that can be used. That's data that can be put back into the system to say, hey, if this happens, this is the condition you will have. That's why sometimes you cut off a piece of equipment and it comes right back up. And sometimes you cut off a piece of equipment and it fails. Or sometimes you cut off a piece of equipment and it's in between. These are things we can do with smart sensors, IIOT. We'll keep beating this in the ground because this is something that everybody that's in any factory that wants to be efficient should really, really delve into.
Yeah. And, at that point, we start moving from, we start taking the home automation standpoint and, start looking at the IoT standpoint and stuff like that. When we start moving away from industry, because the funny thing is, and, with the Industry 4.0, like we were talking about earlier with the Amazon stuff, is that, the IIoT all started from a home use, and slowly but surely got rolled in. Lights turning on and off. Now there's companies doing that to save time and energy and money. Inside their lines when there's not anybody going to be there. You have AGVs of the past. They were big clunky things, and now they're not as big and clunky anymore. But if you look at it, you have like the Roomba. The vacuum cleaner. They also have the mop now that you can use. All those are, versions of an AGV, if you think about it in the grand scheme of things. And, you have the Googles, you have the Alexas, you have, the other Home 2 now or Home Assistant that you can load in a Raspberry Pi. And you can open source 95% of it. If you think about it, freaking Home Assistant can actually talk to a Step 7 PLC. The grand scheme of things, to pull all that data in. But that's for home use.
And here's something that's crazy. We now have more computing power on ourselves than the computing power we use in Apollo to go to the moon.
Yep.
So everybody now has some form of a personal area network.
Yeah.
Well, guess what? There's another thing that's involved with the Internet of Everything, the Internet of Me.
Yeah.
So you also have the possibility of tailoring this Internet of Me to yourself, of using this Internet of Me to automate your home. When I come in, cut the lights on. When I come in, I've had a rough day. You can tell by the emotions from the camera looking at my facial expressions. Start my bath water. Hey, I had a rough day. I really don't want to do a whole lot. Cut on some music to soothe me. Or maybe you want your system to let you know what the traffic's like. Maybe it tells you, hey, I know you normally get up at 5, but today you might want to get up at 4 because you're going to have to take an alternate route to work.
Yeah, geolocation.
These are things that you can do with all these things. Yeah, it's a little bit scary, But I'm finally glad that, we have the capability to do all these things. I am excited that we're able to take these tools and use the tools to help humanity, not just in your home. Maybe we can we will use this in third world countries that don't have the same resources. We will use this in neighborhoods that don't have the same internet access. We will use this where we have a lack in resources for first responders. This technology will be useful.
Yeah, if you think about it, look at the UAV stuff. UAV is the same way now. Using UAV, UAS. Now Starlink, set up by SpaceX and stuff like that. Now giving internet to the globe, and they're assisting first responders with it. And it's like geolocation and stuff like that. Geolocation right now is one thing. You can set up to automatically open up your garage door. When you pull up in front of the house instead of having to use like an RFID or click the button. But like you were talking about the Apollo, If you think about it, Apollo went to the moon on what 256 megs of RAM.
Yeah.
You know, people are carrying around more than that in their cell phones, and most of the engineers that sent those rockets to the moon did on a slide rule. You know, but the thing is that doesn't stop people from learning technology. That's how they got to that point. Now you have these data loggers that are located on launch platforms and stuff like that. It tells them forces, pressures, angles, heat generation by motors, and stuff like that. And feeding all that data back, knowing what your stress factors are of your launch pads. And then when you come in, when you get to the home environment, you're talking about doors being opened. You know how many times that door is activated. All the other stuff. You kind of get an idea. You get told when your batteries are going dead. Out of all things. Then we kind of move into the industrial standpoint where instead of using that data for a scientific approach, or using that data for home use to possibly save us money on our electric bills, but we're now using that data as that new oil, like we like to say, to improve processes, procedures, and things.
And the thing, when we say data is the new oil, it's not controlled by a company.
Right.
This data is controlled by us, people. Now, some of you may be a little bit frightened and weary of this system turned into Skynet. I welcome the Terminators. You just have to know how to program the problems. So what I'm getting at is this. Imagine, if you will, in an industrial plant, I had a sensor that had the capability to machine learn, had the capability to use AI after it learned this machine learning and say, hey, I am in a degraded mode. I need to work at this level. But it was able to alert the system to say, hey, I'm in a degraded mode. Let me reconfigure another sensor to read with me. I'll take these two sensors and we'll read in degrade mode. We'll take the sum of the two, and the sum of the two will give us the whole. These are things that you can do with this technology. I don't have to stop the line to change a sensor. Say a sensor quits reading. I say, ignore this sensor. You two sensors are in proximity. Proximity sensors give me a reading. Those proximity sensors, as long as it's a group reading, can compensate for the one sensor that's missing. Let's give another example. What if something's changed in my tooling? What if my reading distance has changed? Fine. If I have a sensor that can read from 5 millimeters to 20 millimeters, I don't have to set this sensor to read that. This sensor reads at the distance it needs to read because it learned. It learns by which parts are in there. When I have part A, read at 5 millimeters. When I have part B, read in between 5 millimeters and 20 millimeters. And when I have a part that's further away from me, read at the furthest distance. These are things that you can do. These are things that you can incorporate into your ecosystem so that if something's not working, you can compensate. And if you can, I would say, if you can dribble with the other hand, to use basketball as an analogy, you will become a much more profitable, much more sustainable, much more stable company in the future.
Yeah, I can agree with that 110%. And, the big thing is use it to your advantage. Build upon it. Don't just kind of let it go. Because right now we see people out there that they're collecting all this data. They're collecting. And then one day they expire. You can take it and turn and throw it all into, a data field and stuff like that and kind of let it go and, go from there. But, want to data pool and go back and use it later, for some historical analysis. But if you're not actioning on it, then what's the use in having it? And, I think right now we finally got to that point, especially, coming from the IT side, that we're willing to install systems that do this, that are willing to venture past the the Windows servers and the Red Hat servers and the servers that we know and love. We're finally willing to stretch the boundary of what is IoT, what is IIoT, and what is data mining collection that we need to get, using the Power BIs, using the Kibana instances, the MQTTs, the Node Reds, if you really want to get into that, and pulling data from all these different data points, and pulling that all into a database or into a flat file share drive, and being able to eat it later. Come back and look at it as long as the data is actionable.
And I would like to use another everyday thing to maybe enlighten people or maybe make my point a little bit better. Everybody likes milk. Everybody buys milk. Anytime, especially in the South, anytime we get snow or the threat of snow, there is no milk.
Hurricanes.
What if it was possible that expiration date on the milk was a sensor? And it turned a certain color when that milk was close to being out of date.
Yeah.
What if I could take this same concept and take the same concept to a machine, and a machine had this same sensor or this same methodology that it would tell on itself? I say tattletale logic. It would say, hey, just so you know, I'm not sure exactly what's going on, but in probably about 5 minutes, I'm going to have a catastrophic failure and you're going to shut down. What if you were able to control your shutdown? What if you were able to say, okay, stop. Let's mitigate the situation. Let's run some other things, get everything in place because we know what it is. What if I knew what was broken in the system? What if I knew where to go look? Okay, even if I didn't know where to look, what if I was able to isolate it to a part? What if I was able to isolate it to a system? Just like doctors can tell you if a person's having heart failure or kidney failure or liver is not working correctly.
Yeah.
Machines should be at this same level. Machines should be able to give us diagnostics. Machines should be able to give us information we can use. And we shouldn't have to throw a dart at a dartboard and hope that we hit the bullseye.
Yeah. Sometimes I fear that the reason why we're not getting a lot of that is because no one wants to accept the fact that we're heading that direction. It's cost the companies more money to keep people on site to be able to troubleshoot it, and be reactive instead of proactive. And, with Industry 4.0, we're pushing people to be more proactive instead of reactive. And indulge in the machine learnings and the preventative maintenance standpoints and, the knowledge that comes out of it. Using new systems to build better, things. And, that could go from automotive all the way down to, building, plastic containers for to-go cups. It's everything requires a sensor. Everything. And if every company can get on board the Industry 4.0, I guarantee you're going to see the cost of a lot of the consumer goods drop. Because with that, and, I'll give you the floor to lead us out here in a minute, is if you're spending less on maintenance, you're spending less on parts and availability and keeping your lines running more because you understand what your processes are, your procedures, and your issues. You're able to solve those issues beforehand. Now you're paying less. So your price of good is going to drop.
And also your system is reducing waste. Your system is feeding back to say if there is some issues with parts and stuff. But what I would like to end on, Nick said I'm a nerd. Of course I am. I can remember when I was a little kid in Star Trek, they had a communicator. And I witnessed this communicator being turned into a flip phone. I can remember watching the Terminator. Currently, there's a computer that could become Skynet. IBM Watson.
Yeah, that is true.
And with that, we would like to thank everybody for listening again. Thank anybody that gave us comments. We would love any input to get better. We would love any ideas that you guys would be willing to give, so we could maybe address some topics that you guys are interested in. And once again, me and Nick appreciate you guys listening.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.